Hello student, we are going to start a very interesting and new topic, and topic name is the quantum number. Especially in this topic we have to know that what is the interesting point of this topic. First, you know very well that in atom the three fundamental particles, that is the electron, proton and neutron, are present. But here we have to talk about for electron, that is the what is the position of electron in the atom and so on. Clear? So in order to explain these all points, we have to consider a new point. That point is known as the quantum number. Clear? First, I will correlate the quantum number with the human address. Suppose you have to send a letter to your any relative. So what you have to mention on your letter? First, you will write the name of the person. Clear? Second, the state name. Next, the district name, and last one is the pin code number. So I hope that the 4 points are essentially mentioned on the letter, because if we will not mention these all points in corresponding letter, then it will not send to the particular person. Clear? Similarly, suppose you have to talk about for a particular electron in the atom, so we have to consider the topic name is quantum number. Clear? Or simply we can say here that quantum number gives the information of electron in an atom. That means the what is the position of the electron, or what is the energy level of the electron, so on. Clear? So here we can say simply that quantum number gives the information about the electron in the atom. Clear? So the definition are given for the quantum number is: quantum number is that number which gives the information about the position and energy of electron in an atom. Clear? So let's consider here. This is the, I just write here the for human address we write the name, state name, district name and pin code. Suppose any of these 4 one will be wrong, then the particular letter will not be received by the particular person. Understand? So we have to write these all things or these all points in a very clear order or in a very clear manner. Similarly, suppose you have to find or you have to gain the information for an electron in the atom, then we can say that we get the information for electron in the atom, like what is the where the electron are present, which cell present, in cell, subcell, then orbital, and the rotation of electron. Clear? So the first thing is the cell. Clear? Because you know the concept of cell was given by the Bohr, and there are almost 4 KLMN cell, and after all we consider the subcell, and in subcell there is a number of orbitals. That orbitals are considered as the atomic orbitals. Concept of atomic orbital was given by the Erwin Schrödinger. And next, the rotation of electron in the orbital. Clear? So we have to consider the next heading, which is known as the types of quantum number. So let's talk about types of quantum number. Types of quantum number we have to consider, and in quantum number are of 4 types. First one is the principal quantum number. Second one is the azimuthal quantum number. Azimuthal quantum number. Third one is the magnetic quantum number, and last one is the spin quantum number. Spin quantum number. In simply we can say here the principal quantum number gives the information about the cell. Azimuthal quantum number gives the information about the subcell. Magnetic quantum number gives the information about the orbital or the orientation of the orbital, and spin quantum number gives the information about the rotation of the electron. Clear? So these are the 4 quantum number, and each quantum number gives the information about the particular things, that is a cell, subcell, orbital and rotation. So let's talk about what is the principal quantum number. Okay, so we are talking about for here principal quantum number. It is denoted by small n, and it gives the information about the cell, that is the primary energy level for electron. Primary energy level for electron, that is the cell, and its value will be always any integer like 1, 2, 3, 4, so on, but not equal to 0. Here the value of n will not be equal to 0. Suppose if the value of n is equal to 1, then it will be the K cell. N is equal to 2, then it will be the L cell. N is equal to 3, then it is equal to M cell, and N is equal to 4, then it will be equal to N cell, and so on. Clear? So N is equal to 1, K cell, N is equal to 2, L cell, N is equal to 3, M cell, and N is equal to 4, N cell, and the value of N will not be equal to or not equal to 0. Clear? And it is the primary energy level, and it gives the information about the cell. Now we talk about for the second one, that is the azimuthal quantum number. Azimuthal quantum number. It is denoted by small l, and it gives the information about the subcell. Here its value, the value of L depends upon the value of small n here, and it gives, or it is the secondary energy level for electron. Secondary energy level. Clear? Suppose its value L, or value of L is depends upon the value of n, and formula is L is equal to 0 to n minus 1. L is equal to 0 to n minus 1. Clear? Suppose when we put here n is equal to 1, then the value of L is equal to 0, and when n is equal to 1, the cell is K, L is equal to 0, then subcell is S. Clear? N is equal to 2, then L cell, and if n is equal to, when we put n is equal to 2, then we get L is equal to 0 and 1, 2 value. Clear? Similarly, when we put here n is equal to 3, then we get 0, 1, 2. Clear? n is equal to 4, then L is equal to 0, 1, 2, 3. Clear? You can not write here like that. If n is equal to, you will put here n is equal to 4, then 0 and 3 will you get. But you have to consider the previous number also. Clear? And you have to remember the point here. In case of azimuthal quantum number is L is equal to 1, then the subcell will be S. L is equal to 2, then 0, S, 1, P. L is equal to 2, it is D subcell, and L is equal to 3, then it is S subcell. This is the remember point. You have to remember it, that L is equal to 0, then S subcell, L is equal to 1, then P subcell, L is equal to 2, then D subcell, and L is equal to 3, then F subcell. Clear? Now I will talk about for third one, magnetic quantum number. Magnetic quantum number, it gives the information about the orbital or orientation of orbital. Here it is denoted by small m or ml, small m or ml, and it gives the information about the orientation of the orbital and its value depends upon the value of small l. Its value depends upon the value of small l, and its formula is ml is equal to minus L 2 plus L with 0. Here you have to use this formula to calculate the value of ml. Clear? Suppose L is equal to 0 or given. L is equal to 0. Here, and if L is equal to 0, then subcell will be S, and in this case the ml is equal to also 0, and the value of ml gives the information about the orbital. That means each value of ml gives the number of orbitals. So here the value of ml is equal to 0, then it means here only one orbital. Clear? So we can say here that in S subcell there is only one S orbital. Similarly, when we talk about for L is equal to 1, then it will be the P subcell, and in this case ml is equal to minus 1, because the formula is minus 1, then 0, then plus 1. So the total number of ml value is 3. So in this case we consider in P subcell there are 3 p orbital, 1, 2, 3. Clear? Similarly, when we consider L is equal to 2, then ml is equal to minus 2, minus 1, 0, plus 1, plus 2. Total number of value of ml is 5. So in this case the number of orbital is 5. Clear? Here L is equal to 2, then D subcell, and in D subcell the number of d orbital is 5. Similarly, we talk about for L is equal to 3. L is equal to 3. When L is equal to 3, then ml is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So total number of ml is 7. It means here 7 orbital, and here L is equal to 3, then F subcell, and in F subcell there are 7 F orbital. Clear? So this is the number of orbitals. We get the value of this by calculating the value of ml. Clear? Now we talk about for what is the orientation. Suppose the ml is given as -1, 0, +1. So number of ml value is 3 and we can write like this. This is the first orbital, second, third, and this is the three-dimensional space which is considered as the atomic orbital. So the orientation of this orbital is -1, the orientation of this orbital is 0, and the orientation of this orbital is +1. Clear? Similarly, when we talk about for ml is equal to -2, -1, 0, +1, +2. So number of total orbital is 5. 1, 2, 3, 4, 5. So orientation is -2, -1, 0, +1, +2. Clear? So this is all about the magnetic quantum number. I will talk about for the fourth one, that is the spin quantum number. Spin quantum number. Clear? The spin quantum number gives the information about the rotation of electron. Rotation of electron in the orbital. Suppose first we have to consider that in one orbital maximum number of electron will be 2 and its spin will be opposite. Here, suppose this is the orbital and in this one orbital only 2 electron, maximum number of electron will be only 2, and there are the spin of these 2 electron will be opposite from each other. That means if one electron is in a clockwise direction rotation, then second one will be in anti-clockwise rotation. Clear? So we talk about for the spin quantum number, and spin quantum number is denoted by S or ms. Clear? And its value depends upon the value of m. Clear? Its values depend upon the value of m. Clear? Suppose the electron has this type of motion, this arrow, it gives the information about the clockwise rotation, and if clockwise rotation will, then the ms is equal to +12, and this arrow means anti-clockwise rotation. This means the value of ms is equal to -12. Clear? So we get the value of ms, that is the spin quantum number, as a +12 and as a -12. Clear? So this is all about the quantum number and its type. I will talk about for the next topic, that is the shapes of atomic orbital, in my next video. Thanks a lot for watching my video.